Welcome to the listeners of TALRadio English. This is CXO Show Time with Akshay, your host. We are going to continue with Bill Diamond, our guest, who is the president and CEO of the SETI Institute. We have been having a very interesting conversation. And Bill, thank you for staying with us for this episode as well.
As I was thinking through with the kind of research activities that are currently going on, a lot of scientists working all across, which means that there is tremendous amount of data being generated.
Yes.
There need to be to collaborate data to come with some meaningful pieces of information. With advancement of technology and with advancement of technical streams like artificial intelligence and machine learning, how are you leveraging AI/ML towards your applied research?
Yeah, that's another great question. These are really important tools because, as you rightfully point out, all of these endeavors, whether they're things like the Curiosity rover on Mars or the Perseverance rover or the James Webb Telescope or radio telescopes on Earth, they generate massive amounts of data. And in fact, if you talk to scientists at NASA, they'll tell you that there is more data owned and held by NASA that has never been looked at than there is data that has been studied. And so this is a problem that I think is an enormous and real problem across lots of different aspects of society and technology, that we're generating more data than we have the means and the time and the tools to look at. But machine learning and artificial intelligence techniques have come along together with more massive computing resources, supercompute resources that can really help us go through these massive data sets and extract from them meaningful information and knowledge. So we're using those tools all the time. We actually run a program at the Institute called the Frontier Development Lab, which is specifically designed to bring together machine learning experts and AI experts in teams with experts from different areas of science that would relate to a particular topic that we're interested in looking at. And these interdisciplinary teams, there's 2 computer scientists, 2 domain scientists. These are basically early career PhD researchers, and they come from all over the world, from India, Pakistan, Europe, Asia, the US, everywhere, South America. So these researchers come together. They're gathered in teams of 4, and they take on projects that have included earth science, exoplanets, astrobiology, even things like disaster response and recovery, space medicine and astronaut health, heliophysics and so-called space weather, or how the sun and our ionosphere interact and impact phenomena on Earth. So a wide-ranging topics of research that are all about leveraging the latest tools and techniques in machine learning and artificial intelligence. And in fact, it's also what we call a public-private partnership. The public partners include NASA and the U.S. Department of Energy. And we have private partners who also bring resources to the effort, including compute resources, subject matter experts, people who know a lot about machine learning and AI algorithms and techniques, technology companies that operate spacecraft. So our partners include entities like Google Cloud, Lockheed Martin, the Mayo Clinic for medical research, NVIDIA and Intel and IBM, and a company called Planet here in San Francisco. So it's really about public research funds and dollars and private enterprise and nonprofit research coming together to do meaningful work. Where again, one of the underlying premises of the project is dealing with exactly what you asked about. How can we not only handle these large amounts of data that our research is generating, but also process that data into meaningful and impactful knowledge and results. So and increasingly we're doing that. We're doing that in SETI programs too, where we think about, well, what if a pattern that might be evidence of extraterrestrial technology is not the traditional narrowband carrier of a radio signal that we are familiar with here, but perhaps some other pattern in the electromagnetic spectrum that we can only really discern by using things like machine learning and AI techniques. So these are very powerful tools. They're emerging as having, significant application to and importance to scientific research. And in fact, nowadays, increasingly, younger folks studying astronomy, astrophysics, and most of the natural sciences are sort of by definition having to become pretty familiar with and capable with machine learning and AI tools and techniques.
That brings me to the next question. How are you involving the younger generation?
That's another good question, which, of course, that's your job, asking great questions. But where we have different education programs that deal with many different age groups of young people. In fact, these education programs are, from my personal standpoint, one of sources of great pride in the work of the Institute. I think they're so important. Science literacy is really a problem globally. Certainly, it's a problem in our own country. And anything we can do to help, generate a science literate, population is meaningful. And the advantage we have, or one of the interesting realities we have, is that we have a subject matter, i.e. space exploration and aliens and life beyond Earth and astronauts and all of these things, which is inherently interesting, I think, and fascinating to many people. And so the opportunity to take the context of space, where you can talk to young people and you've got their attention, because if you're talking about astronauts and aliens and space exploration, they're excited and interested. And then you can teach them science. And you can engage them. So the premise of our education programs, again, is to take advantage or to leverage the fact that we've got an interesting topic that people young and old can sort of get excited about and curious about. And then we can teach science with context, because science is often taught in the abstract, which works for a small percentage of the population, but doesn't work for most people. And so if you have context like space exploration, like what do you need to know and what problems do you need to solve if you want to have habitats on Mars or send a rocket to the moon or do things of this sort. So that's the underlying thesis of our programs. And we've had programs that have had sort of direct impact on young people. We had a program funded by NASA called Reaching for the Stars, NASA Science for Girl Scouts, in which we developed activities and curriculum and challenges for young girls, actually for all of the 6 different age groups of the Girl Scouts, which start at age 5 or 6 and go up to age 18. And so we developed these activities and projects where the girls could undertake these activities and then earn a badge. And these activities might relate to astronomy and astrophysics, solar system, Earth, Moon, Sun, things of this nature. And when we released the materials for the first 3 badges out of the 6, which for the youngest 3 levels of the Girl Scouts, in the very first year of that program, 65,000 girls took part and got their badges, which was really exciting. And then we after development, released the badges for the older girls, and at this point that program is generating about 100,000 badge projects each year for girls, which means we're reaching and impacting a large number of young girls, which is such a huge and important opportunity. And hopefully, this is the kind of thing that helps young girls think about science as a career opportunity, and leads more of them into STEM sorts of careers and STEM interests. So that's been a wonderful program. We have another program which is for teachers in underserved school districts in the United States at the middle school and high school level, which we call the Airborne Astronomy Ambassadors Program. And it's a program where a school district applies to the program to send teachers, and the school districts accepted into the program will send us half a dozen or a dozen teachers. These are middle school and high school teachers that might be teaching math or physics or chemistry or science or even astronomy. And we give these teachers a 3-month professional development course into a particular type of science, typical type of astronomy called infrared astronomy. And then up until very recently, those teachers would spend a week in Southern California with a NASA airplane called SOFIA, which stands for the Stratospheric Observatory for Infrared Astronomy. And SOFIA was this massive 747 with a 2.5-meter infrared telescope in the back. So another way of describing it is like the coolest airplane you've ever seen. And the teachers would spend a week at Palmdale. They would go on 2 or more flights. These are overnight sorties, 10 hours long each. They get to spend time with the telescope operators, the scientists on the plane, the flight crew, et cetera. And all of this experience is about, it's about immersion of teachers into, actual scientific expeditions and activities. So they get firsthand experience of how science gets done in the real world, and they can bring that experience back to their classrooms. These teachers would go back to their classrooms with the blue NASA flight jacket, looking pretty cool, and they had to integrate their experience into their curriculum. And this program has run for more than 10 years and has been extremely successful. Independent third parties go in to measure the impact of performance on test scores, standardized tests, interest in STEM careers and further education, science literacy and basic science knowledge. And in all cases, the arrows point to a program which is making a positive impact. So that's been wonderful. Congress and NASA finally grounded the SOFIA plane after many years of service. And so we've modified the program now. Instead of the teachers going on this airplane, NASA happens to have another infrared telescope on the ground in Hawaii called the Infrared Telescope Facility. And so now we send the teachers there, but the basic outline of the program is the same. And that program continues to be funded and to bring lots and lots of teachers into these science experiences and have an impact. So we're very, very proud of that project. A newer project we have is focused on community colleges. And community colleges are a wonderful bridge to underserved communities, in fact, and a great stepping stone for many young people into 4-year college programs and other parts of higher education, and open up new career opportunities. So community colleges are a wonderful resource. Many community colleges, most community colleges, interestingly enough, have a survey course or an introduction course to astronomy. And it's taught as a science course for non-science majors. And these tend to be very popular. In many schools, they're the most popular course in the whole school because they're sort of a fascinating topic taught in an accessible and fun way by wonderful teachers. Again, these courses might be the first, last, and only higher education course beyond high school that many of the students taking them will ever have. So the idea that we had was, let's make these classes as impactful and as exciting and interesting as possible. Let's bring NASA scientists, NASA-funded researchers, astronauts, and others into contact with the faculty, the teachers of these courses, and help them make more meaningful and exciting curriculum, even participate as guest lecturers and things of that sort. Bring telescopes to these classes. So we've partnered with a French company called Unistellar to provide telescopes to these community colleges, which are able to work even in so-called light polluted or urban environments. So it's been a wonderful program. By the time that program concludes in, I guess, 3 or 4 more years, there will be around 1,000 community college member entities. So that's very exciting. So our education programs are a combination of train the trainer, like working with community college teachers or middle school and high school teachers, or direct program engagement with young people through partnerships with organizations like the Girl Scouts. We're exploring similar programs to the Girl Scouts with international girl guides in places like South Africa and exploring opportunities in places like India and elsewhere. So these programs are also, scalable and transferable to other countries, other cultures, other languages, et cetera. So there's so much more potential that lies ahead with these efforts.
That's a huge amount of work that is getting involved. And beginning of our conversation, did talk about most of the funding comes from NASA for about 85% of it, right? Centrally funded by the federal government. And I guess that's where you get all the other programs being funded. How do you basically look out for more funds? I mean, is it collaboration with the larger enterprises that helps you out? And what are the activities that you do in kind of raising funds to support all these activities, which are going to be more relevant for bringing curiosity and generating more interest for kids and younger generations to take advanced technologies as they...
Yeah. So those efforts are quite varied in how we undertake them. But another education program we have that I hadn't yet mentioned is we have summer interns from undergraduate and community college institutions who come and spend the summer with our scientists and work one-on-one with a given scientist supporting his or her research. And that's another program which is, I think, now going into its 15th year. And while much of the funding for students participating in that program comes from the National Science Foundation, we also have private individuals, including members of the Board of Trustees of the Institute, who help fund additional students. So we can actually take more students than the NSF funding allows by engaging private individuals or foundations. The Moore Foundation from Gordon and Betty Moore, one of the founders of Intel, has been supporting some of these internships, for example. So there are, of course, different foundations, family foundations, et cetera, where you can actually, like you would for the government, write a proposal and submit a proposal to seek funding for different projects. And of course, different foundations, just like, again, federal agencies have different areas of focus. Some are interested in life science, some in education, some in other areas. So you can sort of identify the foundations or organizations that are supporting programs of the kind we might do. They might even include things like our outreach programming, lectures and radio programs and podcasts and so on. So when you identify those organizations, you can submit proposals to them or contact them. A lot of it is also individual networks. Does anybody know anybody at this organization or that organization? And our trustees come from all over the world as well. We have board members in Asia, in Europe, in the East Coast, and here in the West Coast. And so we tap as well into their networks to see if they know individuals or organizations that can help fund some of the programs that we develop. And we have a development team. It's a small team, but their job is to look for donors and foundations and family foundations that are interested in the kind of work we do and engage those people. And of course, like other nonprofits, these efforts include, sort of the lots of small donations kinds of activities, as well as, the more meaningful major gift opportunities that can fund specific activities. So a lot of work goes into looking at all different types of funding sources. Again, they span from private individuals through to foundations and other organizations up to, of course, government agencies.
Right. And how do you think our audience can engage and support the mission of SETI?
Well, of course, the easiest way is to visit the website, which is SETI.org. And there are, there's a button, I think, right at the top there that says join us, where, you can click on that button and learn about how to get involved, either directly supporting programs that might be of interest to them, or if you're a young student, you can apply for a summer internship. If you've got brilliant ideas on education and outreach programming that we can do, we're always looking for new ideas. We do produce a lot of material for the general public. much of that material resides on our YouTube channel. So if you go to YouTube and type in SETI Institute, you'll see hundreds of lectures on everything from dark matter and dark energy to how to look for life on other worlds to latest technologies in propulsion for rockets, et cetera. So vast range of topics in these public lectures. And every week we're interviewing scientists from the Institute and outside the Institute in what we call SETI Live programs. Those are also on our YouTube channel. And we have a radio program and podcast called Big Picture Science, which really covers all branches of science. And is a wonderful show that includes every month a skeptic check, which is also an interesting perspective on some of the more nonsensical ideas that are out there. So all of these things are available. We do an electronic newsletter that you can sign up for on the website. And in your inbox once a week will be stories of work that we do at the Institute and that our colleagues at NASA and other places do that's related to our work. So there's lots of ways to both learn about what we're doing and get involved. And of course, if one is so inclined to also support that work. We've even had donors join field expeditions to places like the Atacama Desert and the high Andes. So they've helped fund those endeavors, and then they've gone along with the scientists and helped support their work in the field. So lots of ways to get involved, and of course we're always delighted to make new friends.
Absolutely. One last question, Bill. It's a very debatable question. Has SETI ever encountered any alien life or have encountered any UFOs as part of its outreach?
So people are often asking about UFOs. UFOs now often called UAPs or unidentified aerial phenomena. UFOs or UAPs are basically things that people observe in the skies around our own planet that either look odd or behave or seem to behave in a manner that we're not familiar with in terms of conventional flight technology like balloons or airplanes, et cetera, or drones. And there's no doubt that these phenomena exist, that we see things and observe things that we can't necessarily understand. And of course, there's a large segment of the population who, like many of us, when there are things we observe that we don't understand, we'd like to attribute something to their cause. And many people would like to believe that what they're observing is evidence of extraterrestrial technology or intelligence. And while I can't definitively say that's not the case, I also can't definitively say it is the case. I think in terms of UFOs and UAPs, one of the things that we understand about them is generally these phenomena are all based on accidental observation. It could be by a pilot, it could be by somebody on the ground. They are not an observed phenomena that's a result of any scientific effort to study them, which they could be. And we could also be involved in that. We have the technology to, for example, put cameras all over the world looking at our skies for interesting phenomena, but nobody's funding that kind of work. So we're not doing it, but that could be done. But in the meantime, they are difficult to study because there's the only evidence is observational. There's some fuzzy videos or radar images from airplanes or photographs, but they really don't lend themselves to scientific scrutiny that could definitively say where they come from or what they might be. So, UAPs continue to be interesting and potentially important, but we don't specifically study them because we don't have the funding to do that. At the same time, it's important to realize how vast space is, and if people are attributing these technologies to aliens, the first thing that we have to realize is the aliens are not coming from our solar system. So there is no advanced technology elsewhere in our own solar system. So you have to go beyond. The closest place you could go would be Alpha Centauri, which is the closest star to Earth. It's at 4 light years away, 4.2 light years away. And the fastest spacecraft humans have ever built is actually called the New Horizons spacecraft that flew past Pluto in 2015 and has also had rendezvous with Kuiper Belt objects at the edge of our solar system. If you took that spacecraft traveling at its speed and you sent it to Alpha Centauri, it would take 17,000 years to get there. So, the interstellar space is vast. Even if you have light speed technology or fractional light speed technology, it's really difficult to imagine sending that technology over these distances, certainly with any biology on board, unless you're talking about multi-generational spacecraft, basically, a city that's in space that can have generations of individuals, being born and dying on it as it traverses, massive distances. So, the technologies, just the vastness of space and the challenges that imposes on, visiting other worlds, distant worlds, is something for people to keep in mind. And the idea of small objects darting around in our skies, coming from great distances, again, would sort of suggest, well, they didn't come all that way on their own. They would have had to have been part of some mothership or other large craft. Again, where we don't see any evidence of such things. So UAPs and UFOs are interesting, important, but difficult to study scientifically unless funding is made available to do that kind of work. But at the same time, I think it is fair to say that one of the reasons people are interested and have these beliefs is I think we all want to believe that we're not alone. And we often describe SETI as an endeavor, as a hopeful endeavor, because the statistical probability is that if we find evidence of an advanced technological civilization beyond Earth, it's likely to have been around a lot longer than we have. We've been only a technical civilization for about 100 years when we invented the radio. So under those circumstances, we're looking at humanity on this planet where we are challenging our long-term survivability through things like climate change and other potential disasters of pandemic or nuclear conflict, or just population increase, and handling the waste products of human existence. So we're in what one might call our technological adolescence as a civilization. And if we find a civilization that has been around a lot longer than us, I think it's a hopeful message that says, with care and attention, we can overcome some of the challenges of our own making that could potentially impact our long-term survival. So we look at SETI as hopeful, and I think people have their beliefs about UAPs in a similar way, because it's a hopeful outcome to think we're not the only place in this vast universe where life has emerged. So I think these are important notions, but the UFO arena, if you will, is kind of a different domain.
Absolutely. And with that thought, I wanted to thank you for being with us, Bill. A great conversation. I enjoyed it a lot. I don't know how our 1 hour just went through. And I wanted to thank you personally for being there and trying to understand and see how there is some life out there, and try and see if we could learn from out of it, right? It's a great vision that you have, and thank you for taking that mantle and taking it forward with the rest of the scientists over there. Thank you very much, Bill.
Thank you very much. Enjoyed this a great deal, and really wonderful to be on TALRadio.
Absolutely. Same here. We are delighted to have you on board. Thank you.